I just started the recording now, and so once again, please do not leave before I take the roll. I said many times before, but you know, just double check with me before you leave. And also, we will not have class on Wednesday. So you just take the quiz on Wednesday like before. The quiz will be from 3 to 3:15, and we'll cover the content of 1.5, which we will finish today. So that's the quiz. I recently got some questions from some students asking about grading issue in Web Science. Sometimes they say that the system, Web Science system, didn't grade his quiz correctly, and he, asking for some corrections or adjustments. I have talked with the people yesterday with ThinkEdge's technical support, and some of the problems are not from the system. So from now on, I'm not going to make any adjustments for the scores you make in a quiz or test until I receive confirmation from ThinkEdge technical support saying that there's indeed an error in grading in the system. Otherwise, I will not make any adjustment. So if you think there is a problem with the system when you quiz or test is scored, then contact ThinkEdge technical support and get the confirmation from them and ask them to send me an email about this error in grading. Then I can make an adjustment. Otherwise, I will not do that. Okay. Okay, let me see the questions. Is there no way we can get more time on the quiz? We obviously get locked out because we don't have enough time. From the two quizzes we already took, I think most people were fine with the amount of work in the quiz, so I would not consider increasing more time on the quiz. Okay, so many people are saying the quiz is too short. Can you make it longer? Also for some, as I said, from the result I saw in the score board, it's not so bad. I think it's pretty normal. So I'm not going to make it longer at this point. That's for some. Can you put it on VB for someone who can access the other way? As I said before, all the quizzes will be, all the assignments will be done in a web assignment. So not no. Most people, as I checked, as I said already, I checked the two quizzes people took. I think most people were doing reasonably okay for the quiz. So I don't think it's necessary to extend it. Well, if you want to know your grade, your score, you can ask me. But I think some people actually can see the score when they finish. Whenever you submit it, I think it's graded automatically. You can see the score. But one thing I got from the ThinkEdge people saying that try to save your answers every time when you finish a problem. Save it in case you missed something. Save any problem when you finish it. So instead of quiz, can we get some practice work instead of examples all the time? And I'm back to doing the problem. Good, best. I feel like I'm in this. Well, Dijonia, there are tons of practice problems in the book, in the ebook in Web of Science. So you can work on those problems. I think I'm trying to mimic or to give similar problems as the examples in the classes I did. So one way to do it is when you review, and you should review the class, because you got the video recording, I put all the slides in Blackboard in content folder, so you can when you review this, you can do the examples yourself by yourself without looking the right answer. Unless you can do those problems 100% the examples, then you should be ready for the quiz if you can do it without looking at the answer I did. But as I said, you can always go to the ebook in Web of Science to practice problems. All right. I do think you need to practice to learn. Yes, it does not work well for most people if they don't practice. I mean, maybe for all the people, everybody needs practice. I mean, our grade for this class. Yes, yeah, that's what I'm saying. The overall grade is not bad for both quizzes. All right, so we got 17 people now. I guess I'm going to start the content for today. So as I said, we're not going to have class on Wednesday. You just do the quiz on Wednesday by yourself from 3 to 3:15, and then I will meet you on Friday. Okay. So let me just start the material for the course. We were talking about the inequalities, and we didn't finish the part of absolute value inequalities. So let's just continue with that part. So let's just solve the compounding inequality 2x minus 9, absolute value of that less than 7. Okay, as we already did before, the absolute value inequalities usually breaks up into a compounded inequality. In this case, this absolute inequality can be rewritten as a compounded inequality with the part inside absolute value sign 2x minus 9 is greater than 7 and less than 7. So this expression, this whole thing gives a number which must be between -7 and 7, so that when you take the absolute value of that, you get the number less than 7, right? Like the 2x minus 9 can be -6. When you take the absolute value, you get a 6, and that is less than 7. Or 2x minus 9 can be -3, and when you take the absolute value, you get +3, which is also less than 7. Or you can say 2x minus 9 maybe equals 4. And when you take the absolute value, you get 4, and that's also less than 7. So that's why this whole thing 2x 9 must be between -7 and +7. And when you take the absolute of that, and then it will be it will be less than 7. So to solve this compounded inequality as we did before, you add 6 on each part of this inequality, compound inequality. So 9 plus -7 you get 2, and 2x minus 9 plus 9, so you get 2x, and 7 plus 9 you get 16. So it becomes 2x greater than 2 and less than 16. And you divide by 2 for each part, you get the x greater than 1 and less than 8. And because we are dividing a positive number, we don't have to reverse the inequality. So you like before. So it's x greater than 1 and less than 8. So that's the first example. Let's do another one to solve the compound inequality. That's the absolute value inequality. It's not compound inequality. I'm sorry. So there's some typo here. So this time we need to solve the inequality of absolute value of x minus 10 greater than or equal to 2. So in this case, the absolute value inequality will break up into two inequalities. One of them is the part inside the absolute value sine x minus 10 greater than or equal to 2. Like maybe x minus 10 equal to 3. When you take the absolute value, that'd be greater than or equal to 2, right? Or x minus 10 equal to 5. You take the absolute value is 5. That's greater than or equal to 2. So the part inside the absolute value of sine is actually greater than 2 itself. So that's easy to understand. And there's another case when x minus 10 is less than or equal to negative 10, like negative 4. When you take the absolute value, you get positive 4, and that is also greater than 2. So that satisfies the inequality. Or x minus 10 equal to negative 9. When you take the absolute value, you get positive 9. So that's also greater than or equal to 2. So so x minus 10 less than or equal to negative 2. That's another inequality that satisfies this absolute value inequality. And then you just solve each inequality separately by adding 10 on both sides of the inequalities. So you got x greater than or equal to 12 if you add 10 for and 2 on the right side for the first inequality. Or you get the x less than or equal to 8 if you add 10 to negative 2. So you got these two inequalities. And because it is all between those two inequalities, then you actually take the union of those two sets. So those two sets, if you use the interval notation for the answer, x less than or equal to 8, that means all the numbers up to 8. So it includes all the numbers and the positive numbers up to 8. So that will be from negative infinity to 8 with the bracket, right? Or x greater than or equal to 12. So that's all the numbers greater than or equal to 12. So that's starting from 12 and including all the positive numbers greater than 12. So you get the bracket on the left at 12 and the infinity on the right. And you use the union because it is all, so it should include both sets. Okay, so the absolute value inequality is a little more complicated than other inequalities. Any questions on this part? Okay, no question. And then I'm going to checking the typing from your side. Okay, okay. The next thing is called polynomial inequality, and this part is a little more tricky. When you try to solve a polynomial equation, we can do it in different ways, like you did in the quiz. We have probably 4 different ways to do it. And when you try to solve an inequality, a polynomial inequality, like a quadratic inequality, it turns out much more complicated. Okay. And we have 2 different methods to do it. So let's just do it in the first method. So for example, when you solve the inequality, the polynomial inequality of x squared plus 3x minus 4 less than 0. And the first thing to do is factor the left-hand side, okay? And or find the critical values. You factor and you solve the equation. All right. So just to change the less than sign to equal. So we got the x squared plus 3x minus 4 equal to 0, and we solve this equation, okay? And then if you factor it on the left, we got the x plus 4 and the x minus 1, okay? 4 plus negative 1 is 3, and 4 times negative 1 is negative 4. And this set equal to 0 for each factor. So we got the x plus 4 equal to 0, and to move 4 to the right, you get x equal to negative 4. And set x minus 1 equal to 0, you can move 1 to the right, you get x equal to 1. So we got two solutions, and we call them critical values for the inequality, okay? So that's the first step. And then we're going to use those two critical values to divide the whole real number 9 into 3 parts, okay? So imagine you have a number 9 pointing from left to right, and on the 9 are all the real numbers. Then you can mark negative 4 and 1 on the number 9. Then these two numbers will divide the whole number 9 into 3 parts. The first part is from the left to negative 4. So the interval from negative infinity to negative 4. And then you get the part in the middle from negative 4 to 1. Remember, negative 4 and the 1, they are the critical numbers. And then on the right, you just got the everything greater than 1, okay, from 1 to infinity. So, so these two critical values divide all real numbers into 3 sets. Now, then you pick up a number from each set or each part and test the value of the left side of the original inequality. All right? So x squared plus 3x minus 4 less than 0. Okay, that's the the left side of the inequality will be x squared plus 3x minus 4, and you want to know whether that's positive or negative in each of those 3 sets or each of those 3 parts. So how do you know this x squared plus 3x minus 4 is positive or negative in each of the 3 parts or sets? What you do is just pick up any number inside each set or each part and plug in for x and see what you get x squared plus 3x minus 4 is. So, for example, in the set from negative infinity to negative 4, or in this part, you can pick up x equal to negative 5. Okay, so you have to pick a number in this set, in this part. Negative 5 is inside this set, is less than negative 4. Okay, it's on the left of negative 4. So plug in negative 4 for x in x squared plus 3x minus 4. So we got negative 5 squared plus 3 times negative 5 minus 4. And you just do a simple calculation. You got 25 from negative 5 squared, and you got negative 15 from 3 times negative 5. So 25 minus 15 minus 4, if we do get 6, and that is positive. All right? But remember, the original problem, we want the polynomial x squared plus 3x minus 4 less than 0. So that means this is not what we want. So this set on the left, or the part on the left, is not the solution of the problem. It does not satisfy the inequality we want to solve. Okay, then we look at the second part of the second set from negative 4 to 1, and you can pick up any number between negative 4 and 1. For example, you can pick up 0 for simplicity for x, and plug in 0 for x, so we get 0 squared plus 3 times 0 minus 4 if we plug in 0 for x in this polynomial on the left. And we got negative 4. Okay, we got 0 squared equals 0. 3 times 0 equals 0. So we got minus 4. So that's negative 4. That's less than 0. So that satisfies the inequality. So this set satisfies inequality. So that's the solution of this inequality. So that's the second part, the second set. And then we have one more set on the right from 1 to infinity, or one part. Again, you just pick a number between positive 1 and infinity. So any number greater than 1 will work. For example, if you pick up 2 for x and plug into the polynomial x squared plus 3x minus 4, we got 2 squared plus 3 times 2 minus 4. 2 squared is 4, and 3 times 2 is 6. 4 plus 6 is 10. 10 minus 4 is 6. So that's positive, greater than 0, and that does not satisfy the inequality. So this is not the solution for the problem. So the only part that satisfies the inequality is the middle part, from -4 to 1. So the answer is the set from -4 to 1. Any number between -4 and 1 will satisfy this inequality. Any questions? So it gets a little more complicated, all right? So that's the first method. We can call this, testing value method. And then we got another method that use diagrams that makes it a little easy to understand, maybe, if you like. So we can also use a diagram to solve the problem. Again, you do the same thing as we did for the first method. You need to find the critical numbers first. Okay. So what you do is set x squared plus 3x minus 4 equals 0 and solve it till we got -4 and 1 as before. And then you also divide the whole real number set or number 9 into 3 parts, 3 sets as before. Okay, I will. Yeah, okay, I will slow down. Yes, just ask questions whenever you have. So up to now, we're just doing the same thing as we did in the previous page. Okay, so that's why I'm not repeating that. So we just use those two critical numbers to divide the whole number 9 into 3 parts, or 3 sets. From -infinity to -4, that's the left part, and from -4 to 1, middle part, and from 1 to infinity, that's the right part. So you can see the diagram actually shows the number 9 on the bottom, at the bottom. So you got an arrow pointing to the right, and I marked -4 and the 1 on the number 9. Then you draw vertical lines from those two critical values, all right? -4 and 1. And then you check the sign of each factor, x plus 4 and x minus 1, okay? When you try to factor x squared plus 3x minus 4, you get x plus 4 times x minus 1, remember? And that is the left-hand side of the inequality, remember? The original problem is try to solve x squared plus 3x minus 4 less than 0, and we factored the left-hand side by x minus 1 times x plus 4, okay? So then what you do is you check the sign of each factor, x minus 4 and x plus 4, see whether there are positive or negative in each part or in each set. So look at the factor of x minus 1, and then you look at the vertical line at 1. So you can see when x is less than 1, then x minus 1 would be negative. Okay, for example, if x is 0, 0 minus 1 is negative. So that's on the left of 1. If x is greater than 1, for example, if x is equal to 2, then 2 minus 1 is positive. So 2 is on the right of 1. So on the left-hand side of the vertical line through 1, you got x minus 1 less than 0. So we get the negative signs. On the right side of the vertical line at 1, you got x minus 1 positive. So you got the positive signs on the right of the vertical line. Does that make sense? Okay, and then you do the same thing for x plus 2. No? So this diagram shows the number 9 at the bottom, and I marked -4 and the 1 on the number 9. Just Imagine those are the numbers on the number 9. And you draw 2 vertical lines, 3, -4, and 1. So that means you break up into those number line or numbers, all the real numbers, into 3 parts. Okay, one part is from on the left of -4, and the second part is from -4 to 1, and the other part is on the right of 1. Okay, and then you check the sign of x minus 1 for each part. Okay, when x is greater than 1, then x minus 1 will be positive, like x equal to 2. 2 minus 1 is positive. So we're going to get a positive on the right side of 1 for x minus 1, isn't it? When x is less than 1, x minus 1 will be negative. For example, if x is 0, then 0 minus 1 is -1. That's negative. So you put the negative sign on the left side of 1. Does that make sense now? And similarly, you do that for x plus 4. So you look at the vertical line at -4. On the right side of -4, you can pick up a number. For example, you can pick up -3. That's on the right side of -4. -3 plus 4 is +1, so that's positive. So you put positive on the right side of -4, isn't it? On the left-hand side of this vertical line at -4, you can pick up -5, for example. Then -5 plus 4 is -1, so that's negative. So you got a negative number for x plus 4 on the left of the vertical at the -4, right? The vertical line. So you got those negative and the positives on the first 2 lines, and then you multiply x plus 4 times and x minus 1. So on the left part, you got both x minus 1 and x plus 4 negative. So when you multiply them, you get positive. In the middle part, from -4 to 1, you got x minus 1 negative and x plus 4 positive. When you multiply them, you get a negative. Negative times positive is negative, right? And on the right of 1, both the x minus 1 and x plus 4 are positive. So when you multiply 2 positive numbers, you get a positive. So the product of x plus 4 and x minus 1 will be positive on the left of -4, and the negative from -4 to 1, and the positive again on the right of 1. But we want this product to be less than 0, to be -1. Remember, that's the original problem. X squared plus 3x minus 4 less than 0. And that's what we factored on the left. Okay, x minus 1 times x plus 4. We want that to be negative. So you can see the solution is from -4 to 1. The bottom line in the middle, negative, is the solution we're trying to find out. The solution for this problem is all the numbers from -4 to 1. Okay, the middle part. So in notation, as will be from the from -4 to 1. Okay, so that's the diagram method. Now let's do some more examples. Okay. This time we need to solve the polynomial inequality of x squared minus 5x less than or equal to 0. Again, you do it in the same way. First, try to find the critical numbers by putting x squared minus 5x equal to 0. So what do? You factor. So you can factor x out from both terms to get x times x minus 5 equal to 0 and solve this equation. You get 2 critical numbers or values, 0 and 5. X equal to 0 and x equal to 5. And then you do the same thing using the 2 critical numbers to divide all real numbers or real number 9 into 3 sets, as shown in the diagram. The first part will be on the left of 0. So that'll be from -infinity to 0. And the second part, the second set will be from 0 to 5. So that's the middle part in the diagram. And the other part would be either 5 or the set 5 to infinity. So just look at number 9 on the bottom of this diagram. Okay, 3 parts again. And then you just do the same thing as we did. So what we do, we check the sign of each factor of this x and x minus 5 in those 3 parts. So for example, for x minus 5, you look at the vertical line through 5. Okay, so when x is greater than 5, then x minus 5 will be positive, like x equal to 6. 6 minus 5 is positive 1, so that's positive. So that's 6 is on the right side of 5, and it makes positive for x minus 5, isn't it? On the left of 5, if you pick up number 4, 4 minus 5 will be negative 1. So x minus 5 will be negative if x is on the left of 5. So we got the negative signs on the vertical line, on the left of the vertical line of 5, and positive on the right side of the vertical line at 5. Okay, and they do the same thing for x itself. That one is pretty easy. Okay, so you look at vertical line at 0 or through 0. Obviously, on the left of 0, you know, the numbers are negative, and on the right of 0, the numbers are positive. So just x itself, right? So that's easy. And then you just multiply those two numbers, x times x negative 5, x minus 5. Again, you got the negatives on the left set, on the left part, that becomes positive when you multiply them. In the middle part of set, from 0 to 5, negative times positive, you get negative. On the right part, the right side, of 5, you got both positive. For x minus 5 and x, multiply them, you get positive. And again, we want this x squared minus 5x, which is x times x minus 5, to be less than or equal to 0. So there should be negative or 0. Okay. So again, the solution to this problem will be the middle part from 0 to 5. Okay. So the answer is from 0 to 5 for x. So any number between 0 to 5 of x will satisfy this inequality. The difference between this problem and the previous problem is that we are using bracket at the end points of 0 and 5 because the inequality itself is asking for less than or equal to 0. So the end points is included in this solution, 0. Okay. So if you, for example, if you plug in 0 for x in x squared minus 5x, you get 0 squared minus 5 times 0. That is 0. So that satisfies the inequality for x squared minus 5x less than or equal to 0. Similarly, if you plug in 5 for x in the inequality, 5 squared minus 5 times 5, that's also 0. And that also satisfies this inequality. So the endpoints are included in this solution for this problem. So we use bracket instead of parentheses. Remember? So that's the second example by using diagram. Usually, diagram method works a little straightforward. So let's just do some more problems. One more problem, solving a rational inequality. Okay, this time not polynomial inequalities, but rational inequalities. So previously, we did the polynomial inequalities. This time, we're trying to solve a rational inequalities. That means you got rational expression in this inequality. So in this problem, we got 3x plus 4 over x plus 1 less than or equal to 2. Okay, that's called a rational inequality. So how do we solve it? You do it in the same way as you do polynomial inequalities. But first, we need to simplify this inequality a little. Rewriting this inequality by move 2 to the left. So you you have 3x plus 4 over x plus 1 less than minus 2 less than equal to 0. Well, how do you subtract these two? You have to find the least common denominator. Okay, so the least common denominator will be x plus 1. Okay, just like then you do the numbers, and then you rewrite the 2 as 2x plus 2 over x plus 1. Okay, so basically you just multiply x plus 1 both on the top and the bottom for 2. Or 2 over 1. So you got 2x plus, that's why you got 2x plus 2 on the top for the second term. And then we got same denominator, and you can subtract. So 3x plus 4 minus 2x plus 2, you need to distribute the negative sign for the to 2x plus 2, so they both becomes negative, and then you can combine like terms. 3x minus 2x, you get x, and 4 minus 2, you get 2. So it basically becomes another inequality of x plus 2 over x plus 1 less than or equal to 0. And then you can apply the diagram method as we did for polynomials. So the first step is to find the critical values of the inequality by solving the equations of x plus 2 equal to 0 and x plus 1 equal to 0. So you just set the top and the bottom as 0 and solve them individually. This time I have to worry about factoring. You just set the top and the bottom each to 0 and solve them. And then we get the x equal to -2 and the x equal to -1. And those are the critical numbers. And then you do the same thing, just draw number 9 and mark -2 and -1, the critical numbers on the number 9, and then draw root 9s. And then, those two critical numbers, we divide all real numbers into 3 sets or 3 parts. The part on the left, the -2, that's from -infinity to -2. The part from -2 to -1, the middle part, and the -1 to infinity, that's the part on the right. And check the sign of each part for each factor, okay? So for example, if we check x plus 1, so we got x plus 2 over x plus 1, you can check x plus 2 or x plus 1 first, it doesn't matter. For example, if I check x plus 1, then I just look at the vertical line through -1. So again, if you pick up a number on the right of -1, for example, 0 and plus 1, you get positive. If we pick a number on the left of -1, for example, -2, you get -2 plus 1, which is -1, so that's negative. So on the left of -1, you get all negatives, and on the right of -1, you get positives, right? And you do the same thing for x plus 2. This time you look at the vertical line through -2. So again, on the right, you get a positive for x plus 2. If you pick up -1, for example, then -1 plus 2 equals positive 1. So that's positive. If we pick up a negative number on the left of -2, for example, -3, and you add -3 with 2, you get -1. So that gives you a negative number. So on the left side of -2, x plus 2 is negative, right? So we got those negative and positive signs. And then we need to find out the quotient of these two factors. So you got both the negative on the left of -2, you divide the two negative numbers, so you get a positive number. And in the middle part, you get negative for x plus 1, the positive for x plus 2. If you divide them, negative divided by positive, you get a negative, right? And on the right, both are positive, so you divide them, you get a positive for the quotient. And we want this plus 2 over x plus 1 less than or equal to 0 if you look at the second line, the inequality we got after the, some rewriting. We want that's less than or equal to 0. So again, the answer is in the middle from -2 to -1. All the x values from -2 to -1. If you plug in the inequality, it will satisfy the inequality, okay? Now, there's one thing that you need to be especially cautious. We got the inequality with equal sign. So basically, we're going to put the bracket on this set of -2 and -1. So that's why you got a bracket on -2. But on the right of -1, when you plug in -1 for x, you're going to get 0 in the denominator, and that doesn't make sense. So it's undefined. So you should not include the -1 solution set. I have tried. I can tell you the truth. I've tried different ways in the previous class in last semester, and they prefer to use slides instead of writing down. So that's why I'm using slides. But I think the steps are really working. Writing in detail, right? So yeah, please try to do a little practice, and there are also some videos in WebSign for you to watch if you want. If you still got the problems, so you can also call me. I can, after class we can discuss that. Okay. So that's the answer for this problem from -2 to 1, including -1 but not the -1, including -2 but not -1. Okay. So this one gets more complicated as you expect. Okay. So let's do a couple more application problems. A student made 70 in test 1 and 81 in test 2. And he wants to get a C in the final grade, for which the average score of the test is at least 72, below 82. So a C is between 72 and 82, and he wants to get a C. So the question is, what is the range of test scores he needs to make in test 3? So there are 3 tests in total, and he wants the average between 72 and 82 to get a C. So we can use those conditions to set up an inequality. So the average of scores, if you let the x be his score in test 3, the average of those 3 tests will be 70 plus 81 plus x over 3. And that has to be greater than equal to 72, at least 72, right? Below 82, so that's less than 82. And then you just solve this inequality and to the x. So first, you multiply 3 on each part of the inequality. So 3 times 72 on the left, you get 216. And 3 times 82 on the right, you get 246. And in the middle, you just get 70 plus 81 plus x. And then you just subtract 70 and 81 in each part of the inequality, and then you get 65 if you do that on the left and 95 on the right. So at the end, the answer is from 65 to 95, greater than or equal to 65, but less than 95 for test 3. Okay, so he needs to make at least 65 to get a C, but less than 95. All right. So one more problem. Okay, then we are done with this section. Excuse me. The revenue function of a business is R equal to 320x minus 3x squared, $1,000. So that's the revenue. The question is, when is the revenue at least $5,925,000? So this is very straightforward. So we want this Rx, which is 12x minus 3x squared, to be greater than or equal to 5925, at least that. So that's greater than or equal to. And you just solve this inequality. So move 5925 to the left, so it becomes negative. So we got 12x minus 3x squared minus 5925 greater than or equal to 0. And you can start simplifying this inequality by dividing by -3 on both sides of the inequality on each term. And then everything on the left changes sign. And also, the inequality reverses, remember? Because we are dividing by -3. So if you do that, you're going to get the x squared. minus 104x plus 1975 less than or equal to 0. And then you factor the left-hand side. So if you do that, you're going to get x minus 25 times x minus 79 less than or equal to 0. And then you just use the method of solving polynomial inequalities as we did before, either the test value method or the diagram method. You should check by that yourself. If you do that, you're going to get the answer from 25 to 75 for x, including equal sign. So in the internal table will be x from 25 to 79 with bracket on both sides. So any questions for this section? So we're done with this section. Okay, so I guess I'm going to take the row now before we leave. So please do not leave now, all right? Let's see, did I get it? Okay, I guess actually I'm going to do it one more time. Okay, it's not very good. So just wait there, a few seconds for me to take the row. You don't have to. So two students are reconnecting. Okay, so don't leave before I take the row. It only takes a little bit of time for me to take the row. Okay, I got the row now. You can leave. All right. So if you have any further questions, just call me. Okay, since we the audio is not working on your side, I cannot hear you, so you can just call me. You got my phone number. All right, so I'm going to stop the recording now.